Hi, I'm Callie Stoskup, and I am a site reliability engineer, and you are watching the Deploy in Public challenge. This is challenge number 5 in the entire series. So if you haven't done 1 through 4, I'd recommend backing up and starting with 1 because the challenges build on one another. This challenge, we are deploying the exact same application with the exact same infrastructure as last week. We're deploying a very simple Hello World API to multi-availability zones. So that way, just in case one availability zone is down, your application is still live. But this time, the key difference in the challenge is that we're going to be using GitHub Actions to automatically redeploy our applications when there are changes to our code base. This is super helpful, and you're going to really enjoy it once you get it working. If you struggle a little bit while you're getting it to work, it's okay. Struggling is how we learn, and you will eventually get it. Just don't give up. All right. Thanks for watching. All right, we are starting the next challenge for Deploy in Public. And this time, what we're doing is we are going to increase our automation. So last week, we had our Terraform set up to deploy our multi-availability zone infrastructure, but we still had to get into our EC2 instances, our private EC2 instances, and then we had to pull from our ECR repository and run our Docker images. All right. So this time we're going to use the same infrastructure, but we want to be able to automate that pulling and running portion of the process. And we're going to use GitHub Actions for that. But first, I kind of want to just recap our infrastructure. So we have our VPC, all right, and that's going to be our module. Now keep in mind, the only module we're using so far is our VPC, and you're likely going to want to modularize more of your Terraform code. If we have time, we'll kind of keep working through it. But use the VPC as kind of the example and see if you can test yourself to do some of these other things. All right. We have our then private security group. Okay, our private security group is going to apply to our private instances, which we will have 2, 1 in each of our availability zones. We want to allow TCP traffic from our load balancer on the port 3000. And why is that? That's because our simple API that we are deploying runs on port 3000. And then we want to allow all egress traffic. All right. We also want to create the private instances that that security group applies to. All right. And we want to use the IAM instance profile so that way we can use Sessions Manager to get into our instances and use them. All right. We are going to use the user data field, but we are not going to do all of the process on there. You'll see that all we're doing is installing Docker and making sure that we can use Docker. All right. What else are we doing? Well, we're creating our EC2 role. Again, we said that we're going to be able to use Sessions Manager on our EC2 instances. And then we are also going to be able to read our registry information. So we're going to be able to basically pull and run our ECR Docker images on our EC2 instances. So that's what this is all about. Then the next thing that we have is our load balancer and the security group associated with those, the target group and the listeners. So what is all of this doing? Basically, we're accepting all ingress traffic, all right, and all egress traffic to our load balancer. All right, our load balancer is going to be listening on the port 80 for HTTP traffic, and then it's going to forward that traffic to our target group, which is essentially going to be our private instances, and it's going to forward that traffic on port 3000 because that is where our private instances are running. Our application is running on port 3000 within our private instances, so that's how we're going to hit our private instance. All right, so let's move over then to our Now that all of our infrastructure is all ready, I can actually just minimize our Terraform because we're not going to do anything else with it. All right. And then we have our simple API here. So what I'm going to do is I'm going to write hello world, fine. And then I'm going to say something like attempt to deploy one. All right. So that way we can kind of see, because the idea of using GitHub Actions is that every time we push our code to GitHub, all right, our actions will run. All right. And then our application will redeploy itself. And then our changes will be reflected on when we hit the DNS name for our load balancer. All right. But right now, if we log into AWS, you wouldn't see anything on our load balancer. You would see unhealthy health checks because we haven't deployed anything. All we've done is install Docker. We do have our Docker file up and running, so that's exciting or ready to go. So all we need to do now is push, like build our image locally, push it to our AWS repository, and then from our instances, pull that repository. So that's what we're going to do this week using GitHub Actions. I went ahead and I found this article that I think explains building and pushing Docker images to ECR pretty well. So that's where we're going to start. Okay. So this is only going to be half of the puzzle, right? We're going to build the image locally and then we're going to push it. But are we going to build it locally on our computer? No, we are not. We are going to build it using GitHub Actions. So what is GitHub Actions, first of all? All right. So to go over that, sorry, I'm pulling up GitHub Actions, the docs as I'm saying this. All right. So the docs for GitHub Actions are actually super helpful, and we will start going through them right now. Okay. So basically, this is going to help us with our CI/CD, continuous integration and continuous delivery. All right. What is a GitHub action? So basically, what happens is that we are going to create workflows on GitHub, all right, that are triggered when an event occurs. So in this diagram, you see an event occurs, right? And that could be a pull request being opened, an issue being created, a push to a branch. All of those things are different actions on GitHub, right? Those are an event. And then once that event triggers a runner to run a set of commands within a job, all right, inside a container. Okay. What is a runner? A runner is just a virtual machine. Okay. So just like an EC2 instance is just a computer somewhere in the cloud, somewhere not really in the cloud, somewhere just else in the world, right? That's like running our code, running our application. GitHub Actions is going to do the same thing. It's going to devote a virtual machine to us, and it's going to have that virtual machine do the actions, run the scripts, do whatever we tell it to do, okay? Using our code or not using our code, all right? So this could be something like running tests on your code to make sure your tests pass. It could be deploying your code. It could be building a Docker image and so on, all right? So workflows, how do we do them? Well, basically we set up a folder, GitHub folder.github, and then within that folder, we have a workflows folder. Then, all right, GitHub will automatically, all right, read those workflows and trigger them, listening for those events that occur. All right. So, yep, you see, for example, you can have one workflow to build and test pull requests, another workflow to deploy your application every time a release is created, and another one that adds a label every time someone opens a new issue. So, you have a lot of different workflows. All right. An event is a specific activity in a repository that triggers a workflow run. For example, an activity can originate from GitHub when someone creates a pull request, opens an issue, or pushes a commit to a repository. You can also trigger a workflow to run on a schedule by posting to a REST API or manually. All right. What we are going to do is we're going to use on push to a specific branch main. Okay, so typically the way that you would code at work is that you would have main protected, which means that people cannot push directly to main. So right now, maybe when you're coding, what you're doing is you just have your GitHub repo and you are just making commits and you're pushing them and you're working all on the same branch. Well, when you're working with multiple people, that can get messy. So what do? So you would create your own branch. So let's say all of the main code is on the main branch. I, Callie, need to make feature one. So I would check out a branch called Callie's Toast Cup feature one. All right. I would create all my code, right, for that feature. And then what I would do is I would create a pull request, okay, because I want to take my code and I want to merge my new code into that main branch so that way everyone else can use feature one, or a GitHub action to deploy feature one would get triggered. All right. So that's kind of the system that you would have. So then what we're going to do is we're going to set up on push to main, which means that anytime someone manually pushes to main or a pull request is merged into the main branch, either one of those things would trigger our workflow and then would deploy our application. All right, so that's the event part of things. A job is a set of steps in a workflow that's executed on the same runner. So remember, a runner is just a computer somewhere else, all right, that's going to do the job that we tell it to do. Okay, each step is either a shell script that will be executed or action that will be run. All right. So an action is a custom application for GitHub Actions platform that performs a complex but frequently repeated task. All right, so we can write our own actions or use workflows in the GitHub Marketplace. So yeah, so GitHub Marketplace has actions that we can just use ourselves so we don't have to reinvent the wheel. And honestly, a lot of what we're doing this week will not be reinventing the wheel. So you can use actions. Since each step is executed on the same runner, you can share data from one step to another. So for example, you can have one step that builds your application followed by a step that tests the application that was built. You can configure jobs dependencies with other jobs that run parallel to each other. So that would be, right? So here we have job one and then we have job two. And we can say like, okay, we'll only run job two if job one completes and so on. All right, so you can read through more of this. I feel like the runners is a helpful thing to read through. And then you can also see this example workflow here. So why don't we go ahead and I think we'll end this video here. I will put this link in the helpful resources so you can read through it and kind of understand more line by line what is part of a job. All right. Next up, we're going to go through this article in order to figure out how we build and push Docker images to ECR using GitHub Actions. All right. I picked this one because this one was the simplest kind of GitHub Actions push and build and push to Docker example that worked and made sense to my brain. But there's lots of them out there for you to read and kind of go through and figure out kind of how you want to do this. And they all follow similar steps. But yeah, let's go ahead and get started. So prerequisites, we need working code, which our application works. We tested that last week. We need an AWS ECR, Elastic Container Registry, repository. What does this stand for? Registry, and then we have a repository in it. Perfect. And a GitHub repository so we can create a GitHub Actions workflow. And we have one here. Whoop, whoop, whoop. If we go over to the Actions tab, though, you will see bloop, bloop. There's no GitHub Actions yet. Okay. So that's what we are going to be making. And that's where it will appear. All right. Next. So this person is taking an example of Cypress project as part of the blog, but you can build any code and we will build our own code. Okay. So they went ahead and created a Docker file in that to get their project up and running. And we already have one. Yes. All right. So we can go ahead and skip that. All right, next we're going to configure AWS ECR. So for creating the file, we need our access key ID. or secrets access key, our region name, and our repo name. All right. So we already created ours, but we are going to need that information within our repository secrets. All right. So the way that you go about and do that is I will show you. So we're going to go over to our GitHub repo. We'll go to settings. And then there's a few different ways you can do it. So the first way is you can go to environment and create a new environment. So that would be like how you have your dev environment for developers to use, and then you have your testing or QA environment, and then you have production. Okay, there's staging, and there's people call all of these things different names, but basically you have a different environment for the different purpose that you're using. You would want to test your code in a deployed manner before it gets to prod, and so on. So you could create an environment and then create secrets that are specific to that environment, or you can just go to secret and variables actions, and then you can go ahead and go here. All right, so environment secrets would be secrets based on the environment you're in. Repository secrets are just like this whole repository has one set of secrets, okay? So how you create a secret would be you just click new repository secret, and then you put in your name and the secret. All right. So for our purposes, we are going to have to go ahead and figure out what our access key ID or sorry, our secret access key is. I'm sorry, I need to go figure out what our AWS access key ID, and then the AWS secret access key. So we'll have to go ahead and get that information. And part of that is going to be getting the like API, getting the access key from AWS. So if you remember, we go to here and we go to security credentials. All right. And then from there, you can see the access keys you have. All right. So I made one for when I was kind of playing around creating this week's challenge. I made one and to use, and then we had the one that we created in general for, I don't know, one of our other challenges. So yeah, if you don't remember the one that you used and you didn't save it, you can just go ahead and create a new one. Um, and yeah, so let's go ahead and get started. So I'm a little confused as to why my create access key is gone. Maybe you can only have 2 access keys. So let me go ahead and delete this access key here. So deactivate, and then put that in to delete it. All right. So now I can create a new access key. And I'm going to go ahead and just do command line interface because I think that's what it was again. Let me pull it to my other screen so I can go ahead and copy it. I'm going to click I understand. And then next. I'm going to call this GitHub Actions for my description tag, which I guess I can pull this down because you can still. And then I'm going to click Create Access Key. All right. So I have my access key, and then I have my secret access key. Okay, so I can put in each of those, which would be AWS access key ID and then AWS secret access key. So you want to keep those names because that is how the code, if you're copying the code, is going to be used, right? So you'll see here that the AWS access key ID is going to pull from secrets, right? That's here. These are our secrets, okay? And then dot, because it's going to be like the list of secrets or like and think of it like an object with secrets in it, and then we're looking up the specific secret. All right, AWS access key ID. So I'm going to go ahead and make those. I'll pause it here So that way, since I'm making it on another screen and you can't see, but essentially all I'm doing is I'm going to create the secret name, I'm going to paste it in and then add secret. And I'm going to just do that for my access key and my secret access key, and then I will be right back and we'll do EC or repo and region together. All right, BRB. All right, so I have those ends. You can see them here, AWS access key ID, and then AWS secret access key. You can delete your keys and you can edit them. If you click edit, you'll also see that it's not going to like come up with your value because it's a secret. So you can't use this to look up your secrets. And you can edit them. You just would paste in a new one. But okay, so then the new repository secret, this doesn't necessarily need to be a secret. You could have just made this a variable, but because they used a secret and I'm just going to copy their code because I'm lazy, I'm going to keep it a secret too. So US East 1 is going to be my AWS region, so add secret. And then I think the next one is AWS ECR repo. And that is going to be the name of your repo. So it's going to be CWC-ECR for me, and it'll be whatever you named yours in your Terraform docs, but you can check your console. All right, so now we have all of our information here, and let's go on to the next step. All right, the next thing is that we need to create our YAML file. So they're doing it from the console, but I don't like that. So I'm going to do that from my code instead. So what do I do? So the first thing that I need, as you can see, we want a .github folder. So we're going to create a folder and we're going to call it .github. And then within that folder, we're going to create another folder and we're going to call it workflows. And then within that folder, we'll create one that's called main.yaml. I also don't like the spelling of YAML, YML. I like YAML. It doesn't really matter which one you choose, but try to be consistent with the way that you do it. Okay? Perfect. Now that we have our workflow file ready to go, we can go ahead and copy and paste the code into it. All right, so I had it highlighted, but just to make sure, I'm going to highlight it all over again, and I'm going to paste it in. Now, this is what I would recommend. I would recommend not using code that you don't understand, okay? So technically, could I change a few words and push this up to GitHub and it probably would work? Probably. But if you don't understand what you're doing, why are you doing it, right? So our goal in this video is to really understand all of the parts of this puzzle and make sure that we would be able to make edits, that we would be able to explain what we're doing, because a lot of this is already written for us, but just because something's written for us doesn't mean that we shouldn't understand it, okay? So with that being said, I'm going to go ahead and I'm going to make a few edits before we begin, and then I'm going to use Copilot to explain the rest, okay? Now, I am going to use the Understanding GitHub Workflows, okay? So you can see that they have this file here that says kind of the basic structure, and then it goes through and explains what each line does, okay? So I'm going to use this because this isn't like official code. This is someone wrote a Medium article. So let's make sure that we understand everything that's going on and edit things as we don't, okay? So we have a name here, right? If we look here, we see that name is optional and it's the workflow that will appear on the Actions tab of the GitHub repository, all right? So if we go over to Actions here, all right, we don't have any workflows, but it will right now, so it's not going to show up, but it will show up here, okay? So I don't think it makes sense to name that Cypress Docker push. So I am going to change this. I am going to say that my main.yaml file is eventually going to deploy everything. Okay, so I'm going to say, I'm going to call this deploy. All right, and then let's keep going. All right, they have run name. All right, so let's go make sure we understand what that is. The name, it's optional, so we don't need it. The name, the workflow runs generated from the workflow, which will appear in the list of workflow runs on your repository actions. I don't think we need to worry about it, so I'm going to leave it off, okay? On push, right? So we have on, and then it looks like it's in an array push, and then in here, it looks like it's indented 1, okay? Specifies the trigger for this workflow. This example uses the push event, so a workflow is triggered every time someone pushes a change to the repository or merges a pull request. This is triggered to a push to every branch, okay? For examples of syntax that run only on pushes to specific branches, see this, okay? So we could go ahead and open it, but I'm assuming that this is what we're looking at. On push, and then we have paths, and then it looks like there. Paths ignore. All right, it looks like you do multiple. On schedule. I'm gonna just look up branch. It's 182. So that feels like a lot to search through. So I'm not going to worry about it as much, but there is this article if you want to see all of the syntax. This is going to work, so that's fine. Okay, so I am instead going to change this to main. Okay, and so it looks like we could do pushes to all branches, but I only have a main branch, not a master, so that's what we're going to do it. All right, the next thing that we have is jobs. All right, and this groups together all of the jobs that run in the workflow. So right now you'll see, based on the indentation, that we have one job. All right, you'll see here though that this is all in lowercase, whereas this person typed theirs out using uppercase words. I've only seen it only lowercase, so I'm going to change that, and I'm going to call it build and push to ECR. Right? So that's going to be a job. We'll have another job underneath that would be like deploy on EC2 or something. Okay? Or pull and run. We'll see. Okay? Next. So that's the version. It looks like they don't have a separate name. Okay, but here name seems to be just the human readable version. We'll double check with GitHub Copilot after. But anywho, so build Docker image, I'm fine with that. Now let's look at runs on. All right. Configures the job to run on the latest version of an Ubuntu Linux runner. This means that the job will execute on a fresh virtual machine hosted by GitHub. All right, so there's a few different runners since we're using a Linux virtual machine to actually, our EC2 instances are Linux machines. I think it makes sense to use the Ubuntu Linux runner, okay? But this is saying is that we are going to be running this job, which is essentially a list of instructions. We're giving this list of instructions to a computer in the cloud that GitHub is hosting for us, and we're telling it to do these steps. Okay? Steps. So these are going to be the steps that are part of this build and push to ECR job. Okay? The first step that we have is checkout. Okay? And it uses this pre-built action /checkout. So what I'm going to do is I'm going to highlight this and I'm going to Copilot, explain this, and then open this up. Pull this over. All right, and you'll see that we have several steps, and then they're all, so when you see a dash, this is indicating like a new item in the array, okay, of steps. Okay, I don't like the gaps, so I'm gonna close them. All right, so this YAML snippet, right, this part right here, is part of a GitHub Actions workflow. GitHub Actions is a CI/CD system provided by GitHub. Correct. It allows you to automate, customize, and execute your software development workflows right in your repository. The name field is used to give a human readable name to the step. The step is named checkout. So this could be anything, right? It doesn't matter. This is just for me as a human in order to read. So I can leave it as checkout. That's fine. Okay. The uses field is used to specify the action to be used in this step. In this case, actions /checkout at v2 is being used. Right, this is the important part here. This is a pre-built action provided by GitHub that checks out your repository so your workflow can access its contents. The V2 specifies the version of the access to use. In this case, V2 is being used. So in summary, the step of this workflow checks out the contents of your repository. This is typically one of the first steps in most workflows, as it allows subsequent steps to operate on the contents of your repository. So yep, this is basically what's happening. Like when you go and you say git clone and you want to take a look, you want to clone down a repository to your personal computer, you're basically telling the Ubuntu computer, please check out my code. Get my code up and run, like look at it. You can have access to all of the files and then use the code that you see in the rest of the details. Okay. All right. Perfect. So I think we're good with that. All right. Let's go ahead and select this next block here. And we will say Copilot, please explain this. Now, some of this seems maybe a little bit obvious. Some of it seems a little bit confusing, okay? So take more time to look up the parts that are confusing, less time that ones and that are obvious, maybe just confirm that it is what you know, okay? All right, so yes, in this, we're doing a human readable name, AWS ECR details, okay? We're setting those up. All right, and we're using a predetermined workflow, which we're about to go read about. And then we are using these variables with it. All right, let's confirm what we think. It's configuring AWS credentials for use in subsequent steps of the workflow. I think that sounds good, but instead of set up AWS ECR details, I'm going to say configure AWS credentials. That seems more readable to me. Okay, the uses field specifies the action to be used in the step. Here it's using AWS action, which is a pre-built action provided by AWS that sets up the AWS credentials and configurations for use in other steps. Okay, the with field is used to pass inputs to the action. In this case, we're passing 3 inputs. Our AWS access key ID, all right, it's being pulled from the GitHub secret store, all right, which is what we did in the last video where we set that up, all right. The next thing is the secret access key, which again is in our GitHub secrets. And the final thing is our AWS region, which also is being pulled from GitHub secrets, okay? By using this action, the workflow can interact with AWS services in subsequent steps using the provided credentials and configuration. This is particularly useful when your workflow needs to deploy AWS, interact with AWS services, or otherwise use AWS as part of your CI/CD process. All right, so this is like making sure, all right, cool. Yep, this is your account. This is the information. These are your access keys. This is what you have access to. All right, what are we doing next? Next, from the human readable name, it looks like we're logging into ECS, okay? So I'm going to highlight this and have Copilot explain it to me. All right. Don't copy code you don't understand, but you can copy, or don't use code you don't understand, but you can copy code you don't understand and then get to a point where you do understand it, okay? And Copilot is a great tool for that. Reading docs is another great tool. You might want to do that in conjunction. All right. This YAML snippet is part of GitHub Actions workflow. It is used to log into the ECR, okay, which is a fully managed Docker container registry. Correct. All right, I'm fine with that name. The ID, so yeah, this is a new field that we haven't seen before. The ID field assigns an identifier to the step. This identifier can be used to refer to the output of this step in subsequent steps. All right. So here the ID is login PF AWS ECR. I don't really know what PF stands for. If you are able to guess, please let me know. But you can see when I put my cursor over it that we're assigning an ID so that way we can then use the outputs from this step, right, in the next one. I don't like login PF because I don't know what it stands for, but I'm going to change it with login and just get rid of the PF and say login AWS ECR. Okay? And again, this is a pre-built action from AWS. So we're not rewriting all of this. We're using tools that we have written by people who took lots and lots of time to write these tools, right? And we know that they work, but we just want to make sure we understand how to use the tools before we start using them. The V1 part specifies the version of the action to use. In this case, we're using V1. By using this action, the workflow can authenticate with ECR, which is necessary if the workflow needs to push or pull Docker images from ECR. All right, so if this looks familiar to you, all right, it should, because this is what we do every time we are in ECR, right? We log in first, right? We retrieve an authentication token, all right? And then once we retrieve it, then we can use it to build and push, okay? All right. So here it looks like from the output, we're able to get our registry information and then use it in the next step. So let's go ahead, and this is our final step of the puzzle. Let's go ahead and explain this and make sure we know what's going on. All right. And you can also see the similarities. I hope Copilot's still writing, but so here we logged in, here we're logging in manually, right? Then we're building, tagging, and pushing. Here you can see we're building and adding the tag and pushing here. All right, so we're doing the same thing with script that we are doing and with these actions that we're doing manually, okay? All right. All right, so our human readable name for this step is going to be build and push the tagged Docker image to Amazon ECR. I think I'm going to just leave it at ECR, build and push. I'm going to say build and push image to ECR. And then as you can see, yeah, let's change this to log into log log into log into. Would that be it? AWS ECR. And then this one, it looks like we're sticking with capital letters. So let's do build and push image to ECR. Okay. The env field is used to set environment variables for this step. In this, we have 3 environment variables. ECR registry, this is set to the output of the login AWS ECR step, specifically the registry output. This is the URL or URI of the ECR registry that you're pushing to. So when we logged in, all right, let's go back to ECR. Of course, it's not popping up. You can see the URI is here. So that's going to be an output to that login that we did. Okay. All right. ECR repository. This is the set value of the ECR repo secret, which is presumably the name of the repository you're pushing to. An image tag here is set to latest, which is a common tag. Okay. It's just going to be the latest version, right? The run field is used to specify the shell command to run. All right. In this case, it's running 2 commands. The first one it's running is docker build -t, and then ECR registry, right? That's our URI here, okay? Slash ECR repository, all right? Which is going to be this coding with Kali. So I'm guessing this here's the URI that's returned, all right? This is the repo here, and then the tag latest, all right? So the -t option is used to name and optionally tag the image in the format name tag. So, right, this is going to be name tag, all right? Um, then Docker push. This is the command that pushes the Docker image that was just built. By using this step, the workflow can build a Docker image from your application's source code and push that image to an ECR repository. All right, perfect. So we have a better understanding of all of the steps. We rewrote some of it and reformatted some of it to make it work for us. And let's actually give it a try. All right, the moment has come. All right, so I am going to push my code and I'm going to see if it works. So git status. All right, that looks good. Git add, git commit with 2 M's, attempt 1 at build and push workflow. Also, I'm really terrible at commit messages when it comes to commit messages for deployment. So if anyone has a really good system for commit messages that are clear, but often what happens is I'm going to refresh this. Ooh, we have a workflow running. All right. But yeah, often when you deploy, it's like you'll have an error and then you'll like have to change like one word or like one line of code and then you'll find another error and it just gets really like it's a lot of like change a line of code, push it up, watch these workflows, change another line of code, push it up, watch these workflows, right? And so it's kind of funny sometimes when you don't have a good commit to do in the meantime. All right, so let's kind of go through what's happening. So we set up the job, which you can see that we have our runner image getting pulled. You can see that it's then, it's going and getting that action that we requested from like the AWS actions and the GitHub action, okay? Then in checkout, you can see that it's running that checkout v2. The check means it did a good job. Here we have the configure AWS credentials. It looks like we are using set output command potentially, and it's deprecated. We might have to look into that. I think we're actually using a old version of this too. Okay, next we logged in to AWS ECR and we have another warning that our password is not masked, and this one is because of the version, so we can fix that. Then you can see that we built and pushed the image to ECR. And yeah, then it did all the cleanup afterwards. So this is pretty amazing because this never happens where you get a workflow and you do it right the first time. But yes, all right, let's head over to our ECR and let's take a look at what was built. And so, yep, we have our image built. Pretty exciting. Okay, so now what we would want to do is we want to figure out how to run it, right? Pull it down from our EC2 instance and run it. So I'm not going to set up the GitHub Actions for that right away because I want to go ahead and do a test to make sure we did okay. So I'm just going to go to one of our instances. Let's use one. I'm going to go to connect. I'm just going to connect via SSM here. All right. And then I think we can do like Docker version. Is that what we do? Okay, so Docker did get installed properly. So then what do we need to do? So Docker pull, and let's go back to ECR. I feel like it's been a while since I've done this now, huh? All right, so Docker pull this and then tag latest. Oh, we're gonna have to log in. But this also is going to be good memory because it's going to show us what we need to do on the next action. So we need to log in. Then we should be able to pull. Bum, ba-dum, bum, bum. Bum, ba-dum, bum, bum. All right, so while it's doing that, here's what I want to test, okay? I want to test that we are here in, right here in this, and we said attempted to deploy 1. So what I'm going to do is I'm going to change this to 2, okay? Because what I'm trying to make sure that happens is I'm trying to make sure that we can edit our file, okay? So we downloaded it. So now let's do Docker, Docker run. Of course, I already forgot how to. Someone has a really good way to like remember the commands for Docker. Hey, I have it on my other thing. So Docker run --rm -p 3000 3000 and then whoa, what was it called? Um, I think we called it this, right? Latest? Woohoo! All right, cool. Go us. All right, so now what we should be able to do is we should be able to head over to EC2 and we should be able to check our load balancer and make sure that our load balancer in a second has a healthy target group, right? All right, so 2 and a healthy because it does take a minute. So in the meantime, I've saved this attempted deploy 2, and then what I'm going to do is I'm going to push that. So that way we can actually see the benefit of what we just did. So I'm going to say like edited file, okay? Because why do normally, right, when we were manually doing this, we would have to go get all of the ECR commands, we'd have to build the whole thing again, push it up again, right? But now we're just sitting here chilling while our workflow is running again. And it's going to be pushing and updating our files, okay? So let's refresh this. Still too unhealthy, which is sad for us. That is okay. If it's not healthy in a second, I'll go ahead and pause and just wait. All right, so this is building and pushing. So yeah, I'm gonna go ahead and pause and wait for it to turn healthy if it does, and then I'll see you in a sec. All right, we have a healthy load balancer. Well, one of our target groups is healthy, so I should be able to paste it in here and see our hello world attempt 1. All right. Perfect. And then now you can see that our workflow successfully built as well. So if we go back here and we exit, terminate. All right. Let's go back to our EC2 instance. Let's go back to this one. Let's connect. All right, so let's do Docker PS to list. All right, all of our things. Let's look up Docker delete container. Docker RM. So let's do Docker RM. Name of it. Nope. 3. No container. Oh, that's the image. So do I need to do the container ID? All right. Let's see. Nope. Nope. All right. Sorry. Docker commands, they kill me. All right, so let's delete all containers. Can I delete all containers at once? Mm-mm-mm-mm. Do. So Docker stop. And then no such container. That is very annoying. All right. I'm going to pause it here so that way I can get the commands. All right. So I was able to use Docker stop and then the container ID. I'll look into it more later. But basically what I'm trying to do is Docker pull. Let's go ahead and do the same pull command as above because we want to pull down oh, we didn't do it here. So we want to pull and then we want to go get this right? Because we want the latest. And when we pushed up the new version, we tagged it with latest. So you see most of these layers already exist, but we did have to get some new information. Okay. Bum, ba-dum, bum, bum. And then we should be able to do again our Docker run --rm -p 3000, 3000, and then paste that in. All right, perfect. Let's go check our load balancer target group to see if we're healthy, and we're 0 out of 2. I'll go ahead and wait until we're healthy and then resume. 1 second. All right, so we have a healthy target now, so I should be able to refresh this, and yay, we see our deploy 2. Now, you can see that that was a lot, right? I forgot what Docker commands to use. I had to look things up. I got them wrong a few times. I couldn't remember how to delete something. All of that is human error, right? I've started a lot of Docker containers and stopped a lot of Docker containers, right? But I'm still messing it up because we want to automate the things that humans can mess up. So that's going to be our next step, is figuring out how, when we push our code to ECR, we already have it building the new thing, right? If we go and look at the ECR repository, you're going to see that there's a new we have 2 images here, right? And the tag got moved to the newest one for latest. All right. So we're already doing that part, but we need to figure out the next part of, like, how do we get it on our EC2 instance. So this video is pretty much over here. I just, while I paused it, looked up how to run a container in the background because I want to be able to use my terminal after I get it started. So I'm actually going to just kind of do that now. I don't know how to, do I do that? Yeah, see, like, I don't know what to do once I start this. Let's go ahead and terminate this session. All right. I should still be able to, yeah, see, I can still use that because that didn't affect it. But now I'm just doing some exploring because I just want to make sure I understand how to do all of this. All right. So then I go to connect. I'm going to connect. All right. Let's go to Docker. Yes, we have that. So let's go to Docker stop. Let's go to Docker ps-a, which will give us all. Okay, so let's do Docker stop. And so I think what's happening is when we do the --rm, when I stop it, it automatically removes it because right now I have Docker ps-a and nothing comes up. Okay, so I think that's the benefit of using that --rm. But what I'm curious about is I'm curious if I do Docker run --rm, that would be remove, right? And then -p 3000, 3000. And then I go ahead and copy this. All right. I'm curious if I do -d, and I run it in detached mode. All right, looks like I move the -d up. So I'm going to move it here, and I'm going to try. All right, perfect. So see how it started the container, and then, but I still can use it. So now I could say, hopefully, curl localhost 3000, and yay, I could do that. And I don't have to wait for my target group now to become healthy, right? Because now it's unhealthy. Now I don't have to wait because I can just ping there because I'm not actually testing the load balancer right now. I'm testing that my image is updated. All right, so there's that. Okay, so now what I'm curious about, so let's do Docker ps-a again. Let's do Docker stop. And I'm going to get this container ID to stop it. All right, which removes it because if I do Docker ps-a. So now what I want to do is I want to get it up and running again. I'm going to get rid of the --rm because I keep guessing at what that is and I want to make sure it actually, oops. I want to make sure that that's what it actually does. Okay. So I'm going to go get rid of that. So now that started it in the background. So if I do Docker PS, I have the container. So if I do Docker stop and I put in the container ID now, all right, and then I do Docker PS-A, you can still see that I have it, but I exited 4 seconds ago. All right, so that --rm is going to remove it anytime you stop it. So now what I would have to do is Docker rm and then paste the container ID in order to get it to go away. All right, so looking at our workflow run, we have 2 warnings, okay? And I don't not the end of the world, but if we can avoid a warning, let's avoid it. All right, so my guess is, and I went ahead and looked it up too, but my guess is that version 1 is outdated. And it turns out if you look up this AWS Actions configure AWS credentials, you can see that they are already on V4. Okay? So I am going to switch to V4 for this one. Okay. Let's go ahead and I'm curious if the versioning is for all AWS actions. So I'm just going to go back to AWS actions and then curious how we would find that. But AWS ECR, Amazon, ECR login is the other one. So we can kind of go and look through and see. All right, so it looks like they are using V3. Looks like they're also using, oh wait, that's checkout V3. It looks like they're using V2 in the README. And then, yeah, it looks like they're using V4 for configure AWS credentials in the README. And then it looks like they're using V2 of logging and ECR. So I'm going to try those and I'm going to do git status, git add, git commit, edited versions on AWS actions. And then I'm going to go ahead and push those up. And then I'm going to go see if we get the same or different warnings. And hopefully we don't get those warnings anymore. And it was just a simple issue of using not the latest version. All right, so if we open, yay, we don't get any warning and we don't get a warning with that anymore either. Okay, so that is a quick note of things to pay attention to in terms of this article was written November 1st, 2022. It's been 2 years almost since then. Okay, time flies, but it's been a while. So it's always good to kind of check the versionings on things. And you don't want to just copy code exactly. You want to look at it, understand it, edit it for your needs, look at error messages and warnings that pop up, Google different ways of doing things, and come up with your own solution that works for your own use case based on all of the research that you did. All right. So we have started creating our GitHub Actions. We have the build and push to ECR job written. Okay, but we also need to actually deploy it, right? So we need to get to the point where we are in our EC2 instances and we are pulling down the Docker image from the ECR repository and then running it. Okay, we don't want to have to do that manually. So we are going to add another job onto the mix today with deploy. All right, and that will wrap up this week's challenge. Okay. So the first thing that we are going to do is we have our Terraform plans over here. So we'll go ahead and Terraform apply and get that up and going. And so that's going to create all of our things. I'm going to pull down my GitHub Actions while that's loading. So we can look at our repo and look at the settings. You can see that we have our AWS access key ID, the AWS secret access key, the AWS region, and the ECR repo, which is the name. Okay. I shouldn't have to change any of that. You'll see that I did update my access key and my secret access key. And that's because I've just been hopping back and forth between repos, and I really suck at figuring out how to store my keys securely so I don't have to just delete and recreate. So I just delete and recreate AWS keys all the time. That's me problem. Anywho, you should not have to update your keys if you haven't deleted any. Okay? You shouldn't have to update the name either because your Terraform plan is what is creating that name. And same with region, you'll stay in the same region. All right. So that is here. As you recall, when we push our code, that's going to kick off our workflows. And here are the workflows that we were working on a few days ago. All right. So that is going to be our kind of game plan for today, is to add the build or extend another job and extend our workflow and add another job for pulling and running our code. All right. So here's the thing. You could do this all in one job. What would that look like? If it was all in one job, we would kind of probably rename this and then we would just continue to add steps. The benefit of that is that it's less complicated and you don't have to do the same things over and over. All right, because you can use the same runner and the same like environment, right? It's more complicated to add the deployment step as another job, but one of the benefits on that is that if you fail and you want to just retest that one, you can. I think it's easier readability as well. And then as you start deploying to like more environments and stuff like that, it's more reusable. It's up to you on how you want to do it, but I'm going to go ahead and make it a separate job. All right. So let's go ahead and take a look. And yep, we're still creating. Okay. So I am just going to add a second job here while that's creating. You're going to want to do the same indentation as the first job. And so we will call this deploy. All right. And then we want to give it a name. And then we're going to say deploy to EC2. That's fine. You can change all of this. We can run it on an Ubuntu latest machine. That's fine. And then, yep, good job, Copilot. So I'm actually going to rename this one build, just so we can keep kind of short names. But yeah, that's exactly right. We need build to have completed in order to move on to deploy. So when you have multiple GitHub action jobs, they will run in parallel, meaning that if I didn't have this here, they would run at the exact same time. If I add a dependency where I say that the deploy job needs the build job, then it will run one at a time. Okay, and that's what we want, because here we're building an image that we're then about to use. We want them to deploy in that fashion. All right. The next thing that we want to do then is go ahead and type out our steps. So we will name our step, and I'm just going to call this like echo, and we'll just run echo deploying to EC2. All right. So now that we have that, we can go ahead and test that we set up that correctly by saying git status, git add, git commit, and then we're going to say added another job. Git push. Perfect. All right, I am going to open up we don't really need Terraform anymore because we have applied it. But you can see that pushing went ahead and kicked off the run of that workflow. And now you can see that we have these two jobs. We have build Docker image and deploy to EC2. And build is right now 14 seconds in, and deploy to EC2 has not started yet. Okay. What we can do is, since this one actually doesn't depend on it right now, we can go ahead and get rid of this needs build, and I'll show you what that looks like in a second. All right. While we're waiting for it to build and push to ECR, and looks like it's pushing right now, let's go ahead and open up our Amazon and take a look. So looks like we have our repo that was just created a few minutes ago. If we go into it, you can see there's no images yet, but we're currently pushing in this job. So yeah, we still have a few more to push to. All right, and then we'll actually be able to pull and use them. But that's why we want to have the jobs run one after another instead of in parallel, is because there's no image to pull right now. So if it went to pull an image, it either would pull an old image or it would pull a non-existing image. All right. I'm going to go ahead and pause the video while we wait for this to finish pushing, and then I'll show you what it looks like. And it literally completed as I was clicking pause. So let's take a look. So this job is now complete. What does that mean? That means if we refresh this, we should see an image, and that's perfect. All right. In order to see the second image, which is our second job, which is already done, you can click here or go back this way. You can see that it's setting up the job. It's then running echo. The script we're telling it to run is to echo, which is kind of like console log, I would guess, in JavaScript. But it's a way to like print out statements. And anywho, deploying to EC2 got echoed. Okay, perfect. So now that tells you how to set up a job. All right. So what I can do is I'm going to go ahead and comment out this build and push to ECR step because it takes so long. But then you can see that we got rid of the needs. So let's take a look at that. Running jobs in parallel. All right. So this is kind of how you learn as well, is like, even if you finish something and you're like, oh, I know exactly what to do. Like, I know how to do this. This works. Kind of play around with it in order to see. So now you can see that both of them started at the same time. This one just has to do an echo, but see how they both completed in 12 seconds and they didn't run one after another. All right. So that's what the leaving out the needs does, but we need, I'm gonna put it under runs on. We need the needs. All right, perfect. So that is going to be our first step, is just defining that job and making sure we understand how two jobs work. All right. Now that we have the two jobs set up, we can actually start creating the deploy to EC2 step. All right. So I'm going to go ahead and delete this. And the next thing that I'm going to do is I'm going to copy the two steps that I need from first job into my second job. All right. I need to copy configure AWS credentials and log into AWS ECR. All right. So I'm going to go ahead and paste that, and then let me work some magic to make this all line up. And it does. Just trying to make sure. Okay. There we go. So why do we need to do this? Well, they're on two different jobs and they're running on two different virtual machines. All right. Even though they're the same type of virtual machine, it's like running code on two different computers. All right. If I log in to AWS on computer A, I'm not logged into AWS on computer B. So we need to go ahead and use these first two steps again in order to configure our AWS credentials and then log into AWS ECR. And the reason why we need to log into AWS ECR is we need to get the registry from the repository, or we need to get the registry, like that URL. We need to get it from ECR, and that's returned when we log in. All right. So the next step, what we'll do is we'll go ahead and name it Echo, because we want to test that this works as we want it to. And then we are going to run echo, and then we're going to do this. And yep, we are going to echo the output from the login AWS ECR step. All right, we're going to look at the outputs, and then we're going to look at the registry for it. All right, so now that we have that, we can go ahead and do our git status, commit, and push. Okay, before I'm going to do that though, I'm actually going to comment out my build step, my build job. And the reason that I'm going to comment that out is because I'm not changing my code. And the reason why you would want to build a new image is because you changed the code for the application that you're trying to deploy. There's not really a point in us waiting a minute or two every single time we push a change in order to see our deploy code when we already have an existing image in our repository. All right. So in order to do this, to like not waste that time, I just comment out this job and then I comment out this line that says needs build. All right. So now when I push, one sec, added set up steps for deploy. Sorry, I can't think and talk. All right. Or I can't type and talk, I guess. Okay. So let's go back to actions now. And we will see that we only have one job that's running and it's deployed to EC2. All right. So it went and did everything. Let's go ahead and look at these steps. All right. So we ran the configure credentials and it says proceeding with IAM user credentials. Yay. Log into ECR. We logged into the registry. Yay. And then let's echo. And it went ahead and echoed out our registry URI. All right. So that is exciting. All right. So we don't need to echo this anymore. That was just to kind of make sure that this step went okay. But what we do need to do is we need to create the step for deploying to our EC2. All right. So we're going to go ahead and call this deploy to EC2. All right. Then what we will do is run, and then we'll go ahead and do that command so that way we can run multiple commands. You can see that Copilot wants us to SSH, but we're going to actually use Sessions Manager instead. And this is how we're going to do it. All right. So I am on let me go ahead and bring this down. I'm on the AWS documentation, and you can see that we have this command here that is going to allow us to send a command using SSM, all right? And then we'll have a target being our instance ID, all right? And that is going to allow us to basically get into our instance and run a command. Now, you might be asking, why do I need that? Why can't I just run the command like I ran all of these other commands? Well, these commands that you're running here are so that way you are running them on this Ubuntu latest runner, okay? The Ubuntu latest is a computer in the cloud somewhere that GitHub is letting you use, all right? So you're running these commands on it so that way then you can use those commands from and run AWS CLI and stuff like that with Ubuntu, okay? However, when we deploy to EC2 and you are going to run your command, right, you want to run your command that you want to log into AWS ECR, you want your EC2 instance to log in. Then you're going to run a command saying that you want to pull down that image. Well, you want your EC2 instance to pull down the image and run it. You don't want the Ubuntu latest computer to do that. Okay? So, excuse me. So we are going to go ahead and copy this command here, and then we can paste it in, and then we'll have to fix our indentation because we are getting an error. All right. So let's just kind of go through this and make sure we understand what's going on here. So we are saying that we want to use the AWS CLI, and we want to use Session Manager, and we want to send a command, okay? Here we're going to be using the document name AWS run shell script. That just means that we want to run a shell script in the command that we're sending. All right. The parameters are going to then be a list of commands that you're sending in. And here in their example, they're just sending in a hello world. All right. The targets, all right, are the instance IDs then, right? You're going to have key instance ID, and then you are going to have values be the list of instance IDs. All right. I've actually had a difficult time using instance ID with lowercase I and lowercase I here. So I'm curious if we'll run into that too. But yeah, I guess we can give it a try and see. I also am going to move this up. I want the parameters to be last. So I'm going to move them up here for me. All right. Perfect. All right. So our comment is just going to be then what we did in here. So we are going to say pull Docker image and run it. All right. And then in our commands, we can go ahead and we are going to kind of enter down our array so that way we can make multiple commands here. All right. Looks like GitHub Copilot is already trying to do some magic there. But the first command that we want to do is actually going to be retrieving an authentication token. So that way our Docker client on our EC2 instance can use our registry. So I'm going to go ahead and copy this command here, and then we will put it in quotes. All right. I am not going to put the registry like this and hard code it because we don't want to check that into GitHub. But we do have the result of the step before, which can do that for us. So we can go ahead and do this. Steps.login AWS ECR.outputs.registry is going to be the same thing as this here. All right. The next thing that we are going to do is we can go ahead and actually, I think I was going to say let's pull the thing down, but I think what I want to do instead is I actually want to test this. The thing about AWS SSM send command is that it doesn't immediately return. It's kind of like a promise type of a thing, right? So it's going to send the command, but it's not going to return back saying like, we did it, it aired, or we did it, it passed, okay? And you're not going to get the output that you would get from like the terminal if you were to run this, right? Like if I run this in the terminal on my instance, I'm automatically going to get like, yay, you, all right? We're not going to get that. We aren't getting anything back from this. Well, we're getting all of this back from it, right? But you're going to see like, it's not going to say you completed anything yet or you aired anything yet because you have to wait for it to happen. All right. So what we want to do then is we want to wait for that to happen. And then after we wait for it to happen, we want to go and check the results. All right. So in order to do that, we want to do this wait command executed. All right. Trying to find an example of it being used. Bum, ba-dum, bum, bum. Available with this. All right. Well, that's okay. So in order to use command executed, you need to have a command ID passed into it. All right. It's a required thing, and you also need to have an instance ID. All right, so let's back up a little bit. We want to send a command to our instance, but we didn't change the instance here that we actually have to use. All right, so let's go to our ECR and let's get that instance ID so that way we can use it. All right, so I'm going to do this and grab it. All right, and then I can hit comma and not space. That's EC2 1. Let's go get EC2 2. Perfect. All right. And I do feel like I'm going to highlight this and I'm going to say fix this to see if Copilot comes up with any issues. No. All right. Cool. So this looks good. So we have our target is going to be our instance ID. Then we have the instance ID that we're going to run these commands on. And then this is going to be the command that we're running. All right. So the next thing that we want to do is we want to get the command ID out of this, okay? So first, we are going to wrap this whole command in parentheses, all right? So I'm going to do a closing parentheses here and a closing parentheses here, all right? And then I am going to write, I'm going to set up a variable. We'll call it command ID, and we'll set it equal to the output of this command. All right. The next thing that I'm going to do then is I am going to say echo command ID. All right. And I don't actually think I need to name it command ID. I'm just going to do that. All right. So now I'm going to go ahead and I'm going to say get status, get add, get commit, added SSM, send command, command. And then let's push it up and see how we're doing. All right. So again, we are running the command and then we're saving the output of that command into a variable called command ID, and then we should be echoing the command ID. I see that we have an issue, so let's go ahead and see line 10, parameters not found. I think it's because this is wrapped in quotes. All right, I'm gonna try that now. So get status, get add, get commit, fixed typo, I think. All right, and then let's push that up. And hopefully it works this time. All right, so it's running the command. Error. Line 10. Parameters. Oh, I think it's because we don't have the backslash there. Oh, it's saying it can't find our parameters commands. And I think it's because we don't have the slash. Because I moved the order of things, so that makes sense. Hopefully fixed another typo. This is also how all of my deployment commits go. They're always all over the place. All right. Waiting for a runner, getting our AWS credentials. We are mad again. Expected a comma. Let me open this up a little bit further so I can read. Parsing parameters, expected comma for input commands. All right. All right, so I'm pretty sure this is now in quotes. All right. Third time is the charm. Added quote around commands array. Git push. All right, let's try this again. Lots of typos. I feel like every time I'm writing bash, there's like 15 typos, even if I'm like looking at things that I'm writing. All right. You can do it. All right, that looks better. All right. So now here is the output that we got. All right. You can see that. Let's scroll up. So we have our command. So this is our command ID. So like ultimately this is the line that we want here. All right. It ran this command, right? But the issue is that and it has our value, our instance IDs. Okay, so that's good. But the issue is that we don't have a completed count or error count or anything, or because this is just like it immediately comes back. And what we want to do is we want to wait for it. All right. So we are going to come up with another thing. We're to say wait for command to finish. To finish. All right. And then we are going to, I'm sorry, I'm trying to read what Copilot is telling me it wants to say. All right, so now our command ID here is this whole thing, and we want it to just be the ID. So what we can do is after our commands here, we can add a line, we can add a -- query. All right, and then, yep, basically we're going to query and we're going to look for command.command ID, right? So command.command ID. And then we're going to say that the output should be the text. So it's going to plain text, give me this. And then it's going to echo it. Okay. So now that we have that, we'll just run it like this. All right. Filtered output. And again, the reason we're doing this is because we want to be able to take that command ID, send it to another command where we wait for that command to finish, and then go from there. All right. And then so we see our command ID there here. All right. So now we can, it wants to do the third step that we're going to do, but we are not ready to do that yet. So instead, we are going to say AWS SSM wait. All right, yep, command executed -- command ID. That looks good, except I'm pretty sure we need an instance ID as well. Okay, so we are going to do our little backslash there. Or do command ID is going to be equal to command ID, and then we're going to do -- instance -ID is going to be equal to, and so what I'm going to do is I'm just going to, take the first one. You probably would want to loop through and wait for both, but I'm just going to assume that if we wait for one to come back, then we can go get the output. This is probably a little bit lazy of me, but that's okay. All right. And then we can, once we wait for the output to have been completed, then we can actually get the output. All right. So what we want to do is we will say AWS SSM. We already waited for that. We are going to say list command. We want to list all of the commands that we have sent. All right, and we are going to include the command ID because we want specifically to get the information back about that command ID. List commands will list all of the commands that you've run. So if you're running a lot of commands, it would bring them all back in array. Since we know which command that we're looking for, we'll just add that. All right. And then similar to how we did up here, where we wrapped it in parentheses. All right. And then we can just say something like output. I don't want to accidentally, so we're to say command output is equal to, and do the $sign. So now we should be able to run this command, and then we should be able to put it into this variable, and then we should be able to echo our command output. All right, we wrote a lot of bash, and we know that's not my forte, so let's go ahead and see how we did. I'm going to commit this real quick, and then added wait for command and list command. All right, this command output is going to be the same output we had up here, but because we waited for the command to be executed, we should actually get the output back, which would tell us whether or not we successfully completed that step or not. All right, so we're running the command ID. All right, looks like the following arguments. Oh, yeah. So dash dash instance ID are required. Is that not what I have there? AWS. The following arguments are required dash dash instance ID. I felt like I had that. Right. SSM. Oh, do we need to add that? Because yeah, we seem to have a backslash on each one. Let's try this again. Fixed typo, hopefully. A good thing about making yourself type all of this out and then running it each time is you'll start to learn more about like how to write these commands and what's necessary, right? In all transparency, I found a really complicated article that deployed to an EC2 with all of these things and did rollbacks and stuff like that. And then I edited it down to make it more simplified. And then I like made it what I wanted, sort of a thing. All right, so we didn't fail that time, so that's good. So let's go ahead and look at what echoed out. So first we echoed our command ID, which makes sense, that's this, and then we echoed our command output, which is here, so that's good. And it looks like we had a status of a success. All right, so that is awesome. Okay, so what we are going to do now, is we are going to, for this command output, then we are going to filter that because now we want that to be queried. And let's see how we want it. All right, so let's look at it. So commands at 0 dot. All right, I don't know if we want output because let's look at what output. I don't see just a specific output, although that would be healthy. So completed count 2, that's nice. All right, so what we want is going to be status. So I'm going to say dot status there. All right, and then we will do, looks like status and status details, at least for there, are the same. So I actually am going to try status details because I'm curious if it errors, if it gives us more message. All right, so now that's going to output the status details to text, and it's going to save it in this command output. All right, so the next thing that we want to do then is we want to check whether or not our command output is that status, right? So I'm going to actually rename this, and I'm going to call this status. We'll call this status. And I am going to, why is that? Okay. The next thing that I'm going to do is I'm going to look at, perfect. Thank you, Copilot. If status is equal to success, then we're going to echo command executed successfully. Otherwise, we'll execute command failed. And then this fi closes the if block. Okay. So I'm going to try this now. Get status, get add, get commit. Added status echo. There we go. I also feel like I should probably print it out status for if it errors, but hopefully we don't err. All right, so we got our command ID. All right, and we got a success. Perfect. Oh, because we did echo the status up here. Interesting, though, because status is equal to success. So I feel like we should be echoing this, but we are not. Success if maybe we don't need this in quotes. Try this. But honestly, that doesn't really make sense because I feel like either way it should echo something, but removed some quotes. Let's try it regardless. All right. So echo status, success, then echo. All right, so there we go. And maybe I didn't save it right. Who knows? All right, command executed successfully. So that's good. All right. So then otherwise, we want to echo command failed. And I think I want to then echo error status. And then I want to do exit one. So exit one will exit the GitHub Actions workflow and we'll exit it as an error then. All right. So let's try this again to make sure I didn't just mess anything up. And then I'm going to get rid of the echo of the command ID. They don't need that. And then I'm going to add this. I'm going to commit added echo of error and exit if failed. So what I want to do is I want to make sure I didn't mess up the case of it working. And then I want to go ahead and check the case of it failing. And then we'll end this video because it's a very long one. All right, it's doing lots of stuff. Command executed successfully. All right, perfect. So that looks good. So then what I want to do now is instead of logging into my registry like this, with like the actual registry, I'm going to just put something like potato here. And that should fail because there's no registry named potato, hopefully. Try to make it fail. All right. Let's hope, fingers crossed, that it fails. Perfect. All right. So status, we matched expected path, failed. So status didn't equal fail. All right, well, it did fail. I don't see the echo for command failed. So that's definitely interesting because it should say echo command failed, echo error, and then status. I'm curious if it's because of the status details. All right, well, I'm going to end the video here. It did fail, which is what we wanted, and then we'll kind of keep on keeping on in the next one. All right, I did a little bit of research in between now and then, looked at my code from when I was doing GitHub Actions for this, and it seems like here we want to add this or true. All right, and I am going to highlight it and have GitHub Copilot explain it to us, but basically if the instance ID does not work, the or true will allow it to do so. All right, this is the main command. Wait is a command that pauses until a certain action is met, and command executed is the condition it's waiting for. Perfect. All right, this option specifies the ID of the command it's waiting for. And this option specifies the ID of the EC2 instance the command is running on. Or true, this is a shell construct meaning or true. It's used here to prevent the script from exiting if the AWS SSM wait command executed command fails. This is because by default, shell scripts exit as soon as any command fails. So the or true effectively ignores any failure of the preceding command. So basically, this command is failing, we're waiting, but it's failing too early. And so we're just saying like, don't exit out of everything, keep on keeping on, all right? Because we wanna get that status back. So get status, get added or true, get push. All right. Let's go ahead and look into it. All right, we're running our command. Let's hope it works. All right, so we got error failed, command failed. All right. So the session details seems to not be any better, so we're gonna just go with command failed. And then I think I'm gonna be funny and I'm gonna say like, time to get a new job. That's funny. Thank you, Copilot. All right, so I think we'll do that. But really what I was gonna write is time to start debugging, okay? All right, so now that that is working as expected, we wanna actually do all of the things that we meant to do from the beginning. So the first thing is to log into AWS. So let's change this back to our steps.login AWS ECR output registry. All right, and then let's make another command. So this is going to be good. So we want to go ahead and pull from Docker. I don't think we want to just pull secrets AWS repo. I think we want to do steps. We want to pull the registry / repo and then :latest. So that way we get the whole thing. I think latest isn't necessary here because it'll just add it, but might as well be good. And then I'll let Copilot do this, but we want to run in detached mode. Yep. I also want to add the --rm because I want to remove my container as soon as I stop it. I'm not on port 80. I'm on port 3000 on the container and on the application. And then, yep. I also think what I want to do is add a name flag, and I'm going to call this API. All right. I don't know if I need to add this in quotes or not. I'm going to just send it. All right. So let's go ahead now and do get status, get add, get commit, and then we're to say added Docker commands. And let's see how we did. So the nice thing about this workflow is that it's going to tell us if we have an error. The not nice thing about this workflow is we are making some pretty simple commands right now, and we're not doing any sort of like, it's called trapping for bash to trap the error and then kind of output it. So we could definitely get fancier with this. I'm going to not get fancy right now because I think the point is to just get it working. But we could make this better, okay? I will bookmark an article that kind of started all of this with a lot more like fancy of an architecture for all of these. So if you want to make it better, you can go ahead and do it. I think I'll actually use that method for my personal use, but just wanted something easy here. Oh, command executed successfully. Well, that never happens the first time. Do we actually think it did or not? All right. So let's go ahead and let's go to our EC2 instances then. I'm going to open this up. let's go and let's actually connect to them and let's see if we're running anything. So Docker ps-a, we are running something. Woo, woo, woo. All right, so then let's go ahead and do curl localhost at port 3000. And yay, hello world attempting deploy 3. All right, that's perfect. All right, let's go ahead and get into the other one. So that's EC2 1. Let's go to EC2 2 and connect and see if things worked here as well. So let's do curl localhost at port 3000. And yay, we have it. All right, so this is awesome. Now, that took a lot of work to get set up. All right, and that wasn't super fun, but we did it. All right, the next thing that we want to do though to like check that we did this correctly is we actually want to go and change things. And I'm going to say attempt to deploy a change. All right. And then I'm going to comment. Where am I going? Main.yaml. I'm going to comment this back in here. And I'm going to comment this back in here. All right. So that way we can actually build a new image and then use the new image here. All right. So I'm going to do get status, get add, get commit, made change to API, and then get push. Because this is where we're going to see the fruits of our labors. Okay. So let's go to actions. I'll open this up. You can now see our two jobs are going. I'm going to pause the video here and wait for this to build because it's going to take a little bit. All right. I'm nervously awaiting this command to either succeed or failed. Ah! And we failed. It's time to get a new job. All right, well, at least it makes me laugh when I failed. I actually made a little gotcha here. I wanted it to fail because I wanted to show you what's going on. So let's go back to here and let's do Docker ps-a. All right, so if you look, we have here, I'm actually going to refresh the page so it looks nice. Docker ps-a. So we have this container and it was created 4 minutes ago. All right, so if I go and I do Docker pull, let's go to ECR. Nope. Let's just take that. All right. So if I go and I do Docker pull and then I pull the latest, well, you can see I'm not logged in. Let me get logged in first. Nope. Stop it. All right. So if I log in first and then I try to pull, you can see that it's up to date. All right. So let's go check to make sure that it built properly. Well, it did because look, we only had 2 before. We're at 2010. All right. So it did pull correctly and the tag got latest. All right. So we know that AWS login worked and then we know that the pull worked. So the issue is with our run command. All right. So let's actually go and let's copy this. Let's just try to run it manually and see what happens. All right. So we get docker run --rm -d -p. All right, that's looking all good. And then let's copy this guy and let's go. And we sit here, we see the problem. We have a conflict. The container API already exists. All right, it already exists and we can't reuse that name. So what do we need to do? We need to stop any container first that is running with that name before we move on. I'm going to add, oops. Or true, so that way if it errors, we don't get any issues because it will stop this basically will say, if this container exists, stop it. If it doesn't exist, or if it errors trying to stop it because it doesn't exist, we're good. All right. So I can go ahead and say git status, git add, git commit, and then we're going to say fixed typo. Let's just say what we did. Added Docker stop container. All right. So now that we did that, all right, we should hopefully pass the next time. All right, I'm going to go ahead and pause again while we wait for this. All right, it looks like we got 2 checks. Let's go ahead and look and make sure. And command executed successfully. That is exciting. So let's go ahead and say curl localhost at port 3000. And I don't know why it's disappearing on me. But if you saw it there for a second, it did tell us. All right, curl localhost at port 3000. I don't know why it's doing that. That's so weird. Let me try this one. That is so weird. I don't know if this is something that's weird in my thing, but let's try another command, docker ps. All right. So yep, we've got it running up a minute ago. All right, let's just go to our load balancer. Let's check to make sure our target group is healthy. 2 are healthy. So let's go ahead and take a look. Woo, woo! Hello world, attempting to deploy a change. All right, in the next one, we'll test out another edge case, but I mean, we're pretty close, guys. All right, so now that everything is working, we want to test that this adding of Docker stop API didn't break things, all right, when we have no containers. All right, so what we're going to do is we're going to do Docker ps-a, and then I'm going to say Docker stop API. All right. You'll notice that if I do Docker ps-a, I have no containers, and that's because when I started it, I had the --rm. All right. So let's now go to the next one. Let's say Docker stop API. Perfect. And so if we do Docker ps-a, we have no containers. All right. So then I'm going to head back. We didn't change anything to our code here. So we finally get to see the benefit of separate jobs. So let's go here. All right, so basically what I can do is I can go here and, oh, well, not let me. I just want to rerun this one job, right? So this is going to allow me to redeploy and skip over this build Docker image. All right. If they were all in one step, I would have to do like the comment out and stuff like this. But this allows me, if I just change like a configuration on AWS, or I change like a secret or something like that, then that allows me to do it. So command executed successfully. So that's a good sign. Let's go ahead and Docker PS. 12 seconds ago, we had this running. 17 seconds ago, we had this running. Perfect. And we should, yep, we should be able to get the same thing. All right. So now that that is good and our code is good, let's take a look at our code. All right. There's a few things that we could do here to make it better. All right. I think we're at our 2 hours of filming for the week. So I personally am not going to go through and do this, although I guess after this video, I'll count how many minutes we've been recording and see. But this might have to go into next week. Anywho, this could be a step. This could be a step, right? The waiting, and then this could be a step too. All right, this could even be a step down here. So you could go ahead and create more steps that could allow you to like add some more echoes and stuff like that. And it would test that you can kind of like look things up and go for it. Other things that we would want to refactor is we have hard-coded instance IDs. We want to use environment variables instead of that. And then same with our container name. We would likely want that to be an environment variable. That way we could easily change it without changing our code. All right, we might as well do some refactoring. All right, let's give it a try. So the first thing that we need to do is we need to go to our settings and we need to add some more secrets or environment variables, however you want to do it. So I actually did a run through of this earlier. So I already have these variables for instance ID 1 and instance ID 2. All right, so let's go ahead and add those in. All right, so we'll say this is instance ID 1, update secret. Perfect. All right, let's go ahead and edit instance ID 2. Oh, and that included a comma, so we'll have to, did it? Maybe not. All right, that looks good. Add that. All right, so those are updated. So now what we can do here is we can reference them. All right, secrets dot instance ID 1. And then here we can do secrets.instance ID 2. All right, let's copy this because we have one more spot where we put that, and that was here. All right, so because we went ahead and made a change on something, I am going to go ahead and rerun this. I'm just going to run it without the build so it doesn't take forever. We get status, git add, git commit, added instance IDs to env, git push. All right. So now that's only running our deploy to EC2 instance. So we'll go ahead and let that run. All right. So the next thing we want to do is probably get rid of this API here. All right. So let's make that since we didn't command execute it successfully. Let's go ahead and refresh this. Let's do like a hard refresh. Perfect, still works. All right, so let's then do just for funsies. We will do another environment variable, but this time we're going to do, instead of a secret, we'll do an actual environment variable. The difference is it's just not going to be like a secret. So let's go over to the variables tab, and then we'll do new repository variable, and we'll call this container name, and then we can call it API. All right. So now that we have that, we should be able to, anywhere we see API, do we have any other APIs? Just those two. I should be able to replace those with env dot container name. Is that what it's called? Yep. All right, so let's save that. And then let's go ahead and give that a try. Make sure we didn't break anything. Replaced hard-coded API with container name env variable. But that's how you would do an environment variable for container name. You could do like port if you wanted as a variable, but I think that should be okay. Let's go ahead and take a look. Oh, well, dang. Failed. Time to get a new job. Well, that's upsetting. All right. So let's first check. All right, so that still loads. So we didn't mess up that. I'm going to clear some of my tabs. All right, let's do a Docker PS. So that was 2 minutes ago. So it wasn't able to take it down. So that's good. So GitHub Actions, get their environment variable. Get repo environment variable. Mm, mm, mm. Oh, because I'm supposed to use vars, not env. Good to know. All right, so it's just these two spots. So I'm going to put vars. It's been a while. All right, and let's go ahead and try this again. Fixed issue with variables. Git push. I'll go ahead and bookmark this so that way you guys can see that just in case you make the same mistake and you're not watching this video. But honestly, this is a good exercise that we're doing this because I feel like it's testing our code pretty well. And we're seeing that like things are erring when it's supposed to err. All right, so that worked. Perfect. That still loads. All right, cool. Let's go ahead and do a PSA. Looks like it's still called API. All right, cool. So I'm going to say that's enough refactoring for now. Still would say a good exercise would be to separate these into steps. And maybe we'll do that next week. But congratulations, we officially completed this challenge.